Verify 1 minus cosine squared x all over 1 plus sine of x is equal to sine of x. All right, so here we're verifying. Okay, so we do see an equal sign, which makes this an equation. Okay, now you got to be careful. We're not solving anything here, right? What we're trying to do is show that the left side is equal to the right side. Okay, well, how do we do that? Okay, well, we got to use some algebra, do some simplification, apply some identities, okay, and eventually show that the two sides are actually just the same exact thing. Okay, now, just a little hint here, we always start with the more complicated side. If you think about it, the right side in this case just has a sine x, right? I mean, there's really nothing we can do with that. So we want to always start with the more complicated side. And like I said, apply some identities, do some algebra, factoring, canceling out. And then we should see that both sides are equal to each other. Of course, in this case, the left side is more complicated. Let's just write that out, right? 1 minus cosine squared x over 1 plus sine of x. Okay, now, once again, we know that eventually this should equal sine of x somehow, right? All right, we see a cosine squared. Okay, anytime you see a cosine squared or a sine squared, you should always think about the Pythagorean identity, right? We know that cosine squared x plus sine squared x is equal to 1. But what happens when we subtract the sine squared over it? Well, cosine squared is equal to 1 minus sine squared of x. Okay. Now, just a little note here, right? There's always multiple approaches here, right? So I'm not saying that this is going to work every single time, right? But it's always good to try. So let's rewrite that, right? Let's substitute cosine squared x with 1 minus sine squared of x over 1 plus sine of x. Now, you got to be careful here, right? Nothing cancels out. Like the ones don't cancel, and one of these sines doesn't cancel out with one of the sine squares here. Okay, that's just bad algebra. But we do know that 1 minus sine squared of x, right? This is a difference of two squares. We can actually factor this into 1 plus sine of x times 1 minus sine of x. Okay. Let's go ahead and do that, right? Let's replace the 1 minus sine squared with 1 plus sine of x times 1 minus sine of x. And on the denominator, that doesn't change, right? We still have 1 plus sine of x. But notice what happens here. Now, we can actually cancel the 1 plus sine of x, okay? Because this is a single fraction. These are times, though, right? We're multiplying two things together. So this we can cancel out. Okay? You got to be careful with your signs here. We have 1 minus sine of x. And once we distribute that minus, we get 1 minus. And once we distribute the negatives, you get 1 plus sine of x. Look what happens here. Okay? These cancel out. Notice what we are left with. We are left with sine of x. And wait a minute, that's just the other side here, right? Notice what we've done. We've taken the original expression. We've used an identity. We factored out the identity, and then we canceled out, we simplified, and voila, right? We have reached the other side of the equation. Of course, each step along the way, you do want to make sure, right, that you're doing the correct algebra, you're keeping track of your signs, right, simplifying correctly, distributing correctly, okay, and make sure that you always look at the other side as well, okay? And then eventually, yes, if you've made no errors, right, and you've used the correct identities and done the correct algebra, and eventually, yes, you will get to the other side here, right? Most of the time, you're not going to do more than 4, 5, 6 steps, okay? If you find yourself going in circles, probably a good idea to, you maybe made a mistake somewhere, okay? So always, if you're doing more than maybe 5 or 6 steps, right, maybe a good idea just to restart the problem again, maybe do a different approach.